Hey class, I wanted to take some time today to go over the different tools that we need in order to get started. There's a lot to go over. Some of the stuff is tricky to install. And then once we go over it, I want to step through how you would accept assignment in this class, work on it, and turn it in, because that can be maybe a little tricky too. The first thing is we need somewhere to actually write our code, right? There's When it comes to writing code, there are two terms that are thrown around. One is called a code editor, and another one is called an IDE. Both are valid. One is more lightweight than the other. So, both of them are a place where you can write and manage your code. A code editor is lightweight. It cuts a lot of the fluff out that an IDE has. It still has some basic features such as syntax highlighting, so it highlights what code you're writing. Um, some of them might have a debugger like VS Code. Most do not, though. Um, Code completion, line numbers, really basic things to get started writing your code. An IDE, which stands for an integrated development environment, is all of that plus way more. Um, an example of an IDE would be Visual Studio, and an example of a code editor would be Visual Studio Code. So I know it's tricky, but there's a difference between those two things. In this class, we are going to use Visual Studio Code. So we're going to use a code editor. The reason being is it's lightweight, like all code editors are, but there are still a few features that are really nice. For instance, it does have a debugger. It also it integrates GitHub, which is like version and source controlling. So those two features alone, in my opinion, make VS Code a really solid choice for this class. If you were working, doing like bigger projects, I would suggest probably Visual Studio. But for this class, VS Code is going to do the trick. So we're going to start with that. To install it, you can just Google Visual Studio Code. Visual Studio Code, the logo is blue like this. Visual Studio it's that purple logo. So make sure we're looking for this blue one, VS Code. You can just hit download here. And then depending on what your operating system is, you'd hit that. If you use Mac, it's really simple. It's like installing any other Mac application. Windows, what makes it a little different is you go through the installation like normal. There is one option you need to make sure that you are checking, and that is make sure that you add it to the path environment variables. So with everything that we're installing today, you need to make sure if you're on Windows, it needs to be added to the path environment. These installers will ask you to do it automatically. Check yes if that's an option. If you missed that step, then you're just going to have to YouTube or Google how to add it to your path environment. It's really simple. I have a Mac, or else I'd show you. It's really not that hard to do, and if you need help with it, you can reach out to me. So anyway, just make sure you're on VS Code and install on the right operating system, and that's pretty much it on that front. Once it's installed and then you've added it to the path environment, look at my baby. I'm going to open up a window right here. This is what it's going to look like. So you'll notice on this left-hand side, you might not see all these features at first, but what you want to do is you want to go to extensions here. And there's lots of extensions you can install, but the ones that we are worried about is this C++ one. It's by Microsoft. Just make sure you hit install here. This is what gives us all the things we need to code in C++. The other one we want is CMake Tools. not CMake, CMake tools. It's once again Microsoft. You want to hit install on that. That's really, really important. Other than that, let's see. And then I've installed Python. We're only going to need Python for the first week, so make sure you install that. And then lastly, I'm pretty sure. I just wanted to make sure if I installed any Git. I don't think I did, so we're not worried about any of that. So yeah, so just those the CMake, C++, and Python. Once you install that, you should be good to go with the Visual Studio aspect. Okay, before we jump into coding on this, let's go to the next thing that we want to install, and that is CMake. So it's cmake.org and then /download, and that'll get you to a page that looks like this. You want to scroll down and you want to look for your operating system. So yeah, so this would be the Windows installer right here, Mac, right, Linux, and you just want to make sure you get the newest release. I have 3.29.3. So just a little insight on what CMake is. I explained it a little bit in my last video, but when you are coding in C++, you are often going to have multiple files, right? And we'll learn this semester, but you're going to have like header files, and then you may have multiple .cpp files. And all of that code needs to be compiled and be brought together into one executable program, right? So think about like clicking on an icon on your desktop. That's an executable program. And when you compile your code, it needs to kind of all come together into one executable. To do this by hand in the terminal is possible, but tricky. And so it requires you to link the files together. It's called a linker. CMake does that for you, and that is probably the best thing about CMake is it takes all of your files, it links them all together and makes that executable for you. Another huge benefit to CMake and why it's required in this class is because we all have different operating systems. Like I said, I'm running a Mac. I'm sure most of you guys are going to be running on Windows. That makes things tricky because you have to have a compiler installed on your computer, and different operating systems have different compilers. For instance, MinGW is probably what most of you will have. I have CLang, which is kind of Mac's built-in compiler, and just running off different compilers makes things not always compatible with one another. So if we all have CMake, it actually looks at those differences and puts it into one common compiler. There's a lot of them to choose from. Ninja is one of them. CLion. There's a whole bunch. Anyway, that doesn't matter. But that's the other big reason why we want to use CMake in this class. So to install it, it's the same thing. Just use the installer. Make sure, once again, you add it to the path environment variables, right? So install that, and then you should have already got that CMake tools extension in VS Code, and you should be good on that front. The next thing that you want to install is Git, not GitHub. GitHub is a website, which we'll be going to next, but Git is an actual software. So right here, it's this little red logo. Go to the website. You can go to downloads right here, and for Mac, for Windows, for Linux. Once again, this one is pretty easy. Follow the instructions, add it to the path environment variables. You should be good to go on that front. Just so you understand what Git is it's software for source control. So this is a really big deal if you work at a company and maybe you're part of a team and you're all working on one big project, but like different parts of it. One person might want to work on one part of it, another person want to work on another part of it, and then maybe you get done with your part, and then you need to pass it off to another developer or supervisor to test it or whatever. That can get really tricky really easily. With Git, you're able, and it has its own language and verbiage and weirdness, but you can actually take versions or copies, they call it clones, of this code, and then you can make branches and you can modify it and then you can push it back up. Like I said, there's a lot of verbiage here, but the important thing to know is you can take the code, modify it, take a copy of it, and then you can push it back up onto some cloud service such as GitHub, which is where we're going next. So hopefully that made sense. But Git is the software that you need to install for that. Okay. Once you have Git installed, you actually need to have some sort of source control platform that holds the online repositories, is what they're called, the online versions of your code. There's different ones you can use, but by far the most popular and the one that we are going to use is GitHub. And you guys probably have heard of this before. And it looks something like this. So you will need to make an account for GitHub. It's free. Yeah, I kind of wonder what it looks like when I sign out here. I don't want to sign out. I'll probably forget my password or something. But anyway, it should be pretty intuitive how to sign in or how to sign up. And then once you're in, you should see something like this. So this is my personal account. You can go to your repositories and you can see kind of the different repositories, right? So for example, one we're going to be looking at later is the C++ example. So when I click on it, you'll see these are the files that I have, and you can actually you can get the URL to the repository, and that is how you will kind of pull that code down to your local machine and make the edits you want, and then you can push it back up to your repository, or you can clone it to a different repository. So anyway, looks something like this. So you will want to make sure you make an account to GitHub. Okay, hopefully you're following me still. Now, let me walk you through kind of an example assignment, what that looks like. So if you're on your Canvas course, you would actually probably be looking through like whatever week you're on. For this example, I put this little example assignment here in resources. If you click on it here, you may have like a description, maybe a little bit of what the assignment's about. But the big thing is you're going to have this link right here. This is a link to a version of GitHub called GitHub Classroom. It's a place for teachers to set up classrooms so students can have their own repositories on GitHub, all linked in an environment that's built like a classroom, right? So I can like make assignments on it, and then you guys will accept the assignments and then clone the repository that holds the assignment files and then turn them in. So every assignment you do, you're going to have a link here. So you're going to copy the link and paste it right here. It's going to take you to this. This is the name of the assignment that I've created. And it says, once you accept this assignment, you'll be granted access to, this is the name of the repository. And each student is going to have their own repository for whatever assignment you're working on. So that will be the name of your repository. This is the organization that I've created, and it's on GitHub. So you hit accept assignment. All right. So it says you've accepted it. This right here is the link to your repository. So if you click on this, notice how it takes you to GitHub. These are the starter files that I've created for you. Yeah, notice it's your own little repository, which you can see up here. This is our organization that we're a part of. This is our class, and then the /, and then this is the name of your repository. But all you really have to do, you don't have to click on it if you don't want to. You literally just have to copy the link, right? So once you copy the link, you are going to want to open up VS Code like this. And this is what it should look like at first. And I'm assuming that you've already installed your extensions, right? You want to click on clone git repository. As soon as you click that, you'll get this little pop-up. Clone from GitHub. All you have to do here is paste that link, right? Hit enter. This is asking you where you want to save your repository. You can save it wherever you guys want. I'm just going to put it in the desktop because that is simple. Select as repository destination. Would you like to open it? Yes. Okay, this part is telling you which compiler you want to use. So remember, a compiler, since C++ is a compiled language, we have to have a compiler. So basically that's taking your code and it converts it into machine code for your computer to process. That's what a compiler is. Everyone will need a compiler. By you installing CMake, that already deals with installing the compiler. So if you've installed CMake correctly, you shouldn't have a problem here. There's a lot of compilers that CMake uses, so you may have a couple options to choose from. It shouldn't matter which one you choose. You can scan for kits, so this searches for the compilers on your computer. You can let CMake guess which compiler and what environment to use. I always go here. My Mac has CLang installed. That's my compiler that I use. So I'm just going to click that. And it's mad at me. Of course it's mad at me. Please hold. Okay, yeah, it wasn't actually mad at me. The problem is the starter file I gave you is incomplete on purpose. So it was just letting me know that my program wouldn't compile, which obviously I got to make it. So the first thing you'll see here are a couple folders, right? And then this text file. In fact, there are a couple folders in here that it didn't make. Anyway, in every assignment, you're going to have this source file, this src. You're also, I'm going to make it so you guys can see. You should also have the include, I think that's what I usually call it, the include file. And then I usually make a files. So anytime you get an assignment, you should see something that looks like this. This GitHub one is set up for GitHub. So you shouldn't have to worry about touching this. Don't touch this. Build, you also should not touch this. This has like the CMake stuff in it. No touchy on these two things. Files, this is where you would put, we're not going to get into this till the end of the semester, but at the end of the semester, you guys are going to be writing things out to a file, reading and writing to files. You'd save that stuff in this folder. So you're probably not going to need this for most of the semester. Includes, this is where I'd write the header files. Once again, you're not going to need to worry about this for a while. You'll know when you know. A few weeks into the semester, we're going to go over header files and how to make them, and that's where we would put them. SRC, this is where our starter code is. And C++ ends with the extension .cpp, right? And in source is where you're going to have your file that you're going to use. This last thing is cmake list.txt. You don't need to worry about this either. This is a text file that I use to kind of set up your project with cmake. So don't worry about that. So honestly, all you have to worry about is this right here. Now, there will usually, I didn't do it for this one, be another file that is, the naming convention I use is the name of your file _ test.cpp. We're going to go over this another time, another video. But that is a file that I write to test your code. And you are welcome to open and look at it, but do not edit it. You're in trouble if you edit it. Don't do that. But right here, open this up and notice that I have this comment and it says to do. With my assignments, I try to set you guys up as best as I can, and then I write these little comments instructing you what you need to do at this part. So this is just an example. So I put was to do display hello class to the console. So to set up a C++ program, you need to start with this. It's called a directive. Include input output stream. And we're going to go over how to do this next week. So don't worry about this too much right now. I'm going to be using namespace, std. Get your mind out of the gutter. It means standard. And then int main return 0. So I know that looks like gibberish to you guys. Don't worry about it too bad or too much. Okay, I want to display hello class to the console. So console out, cout. That's called the extraction operator. I'm going to put hello class extraction operator end line semicolon. Okay, please do not get overwhelmed by all the gibberish I just wrote, okay? That's not the point of this video. The point of this video is to show you guys how to turn in things. So don't stress. Something's mad at me though. I don't know what's mad at me. Okay. Now, to run this, to compile it and then run it, no touchy up here. I know this play button looks intriguing. Don't touch it. You want to go down here, build. This is the debug. This is to launch the debugger, which we will go over that another time. And then our play button, okay? So hit build. See, it is mad at me. Okay, please hold. Okay, silly me. I made a mistake on my cmake text file. So anyway, everything I said is true. No touchy up here. Build, and you should see build finish with exit code 0. If this is anything but 0, that means there was an error compiling. So that's good. Once it's built, you can hit the play button, or you can hit the debugger to go into debug mode, which we're not going to do right now. Play button. Hello, class. It worked. So there you go. So I run test cases. I'm going to go over this a different time. Assuming that your program passed all the test cases, you did as what was instructed in the assignment. Let's say you feel good about it and you're ready to turn it in. This is what you do. This right here is the source control. This is Git. Notice that there's 85 pending changes. That means I added 85 things, and the reason why that's so many is because I rebuilt the CMake stuff. So you hit this, and this is telling you everything that you did, all your changes. You don't need to worry about all these too much. U, I believe, means updated. D means deleted. M, modified. That's right. And then what's the U again? Yeah. Oh, untracked. Okay. Untracked means I have not committed these yet. And then D means deleted. Okay. What's important here is this. You need to write a message. And this is you documenting what you did. I highly encourage you guys to commit often and make good documentation of what you're committing. The reason why you want to commit often is one, it's good practice because if something goes wrong, um, and let's say the files get corrupted or deleted from your computer, if you've been committing often, that means GitHub has backups since the last time you committed. That's probably the most important reason. The other reason for this class, why I want you to commit often, is because it's a way for me to track if you guys are cheating or not, essentially. So let me give you an example. Let's say I give you a homework assignment and you do one commit. I go and I look at that one commit and I see that you went from 0 lines of code to 500 lines of code instantly. That tells me that you copied and pasted, right? You went to ChatGPT and it wrote it for you. You copied it, pasted it, committed it. That may or may not be true, but you're going to be covering your butts a lot more if you're committing often. So I see, a few lines here or there, 20 lines here, 30 lines here, whatever you've been committing. So anyway, you would type in your message here, and I encourage you once again to write a message that reflects what you did. That just helps you and me. So I would say added output to console. Okay, hit commit. Now you want to sync your changes. This pushes what you committed up to the online repository. Okay, sync changes. From here, you should be good to go. Because I'm OCD and paranoid, after I do this, I do the following. On Mac, it's Command-Shift-P. On Windows, I think it's Alt-Shift-P. You push that, and then it brings this thing. You want to type in the word git, and you want to push, right? Push means to push your code. Pull means to pull the code. Clone means to grab code from a different repository. And we're not going to worry about branches. We're not going to learn about that in this class. So if I made a change, let's say I put out an assignment. You all accept the assignment and are working on it. And then I'm like, dang, I forgot I need to add something to your assignment. I can add that to my repository, and then all of you can go and you can pull, right? Because you're pulling from my repository. You can pull the latest changes. So pull means you're grabbing it from the repository. Push means you're pushing it from your machine to your repository. Okay. So I'm gonna git push, and you should be good. Okay. Now what you can do, if I can find it. Oh, I kept it open. Sweet. You can go to your repository, and hopefully this worked. Source. This is the file that we modified, and you can see it had the changes. So this is a way you guys can go into. In fact, I encourage you, very strongly encourage you, once you push your changes and commit them, to go onto your repository and open up the file from GitHub and make sure it has everything. Because this is what you're turning into me, right? So you need to make sure it has, you pushed everything correctly, because I wouldn't know the difference, right? Okay, once you feel good about that, go back to your repository, your link right here, copy that. Now, back in Canvas, click on the quiz, and notice you're in a quiz now. And question 1, upload the link to your assignment repository here. You would paste that, and you would submit the quiz. And then what I would do is I would, for each of you, I would open up your repository, and I would be able to look at the code that you pushed. I would look at the changes. What's really, really cool about that is I can look line by line at what your changes are, and I can insert comments. So I can be like, hey, you're really close here. I think there's a bug, and I think the bug is here. And that's a way we can communicate. So you can then pull that code back down, and you can see the comments that I inserted, and you'll be able to kind of mess with things. So a lot of cool stuff with GitHub. I know it was a fire hydrant of information. Do not get discouraged. Repetition and practice is going to be the best thing here. So I said a lot. I threw a lot of vocab at you. Please reach out if you have any questions. I will help you, I promise. Okay, that's all I have for this video. The next video, I'm going to jump into the lecture a little bit. We're going to take a step back and look at Python. But yeah, it's going to be real fun. Okay, thanks guys.